Welcome to our channel. Today we're diving into the heart of our solar system to uncover some mind-blowing facts about the sun that you probably didn't know. You know the sun, that giant ball of plasma in the sky that makes life on Earth possible? Yeah, that one. We often take it for granted, but this celestial powerhouse is far more fascinating than you might think. Over the next few minutes, we'll be exploring 10 incredible facts about the sun that will leave you in awe of its power and complexity. From its scorching core to its dynamic atmosphere, we'll uncover the secrets that make our sun so captivating. So buckle up, space cadets, and get ready for a cosmic journey. Let's start our journey by venturing to the sun's core, the very heart of this celestial giant. This is where the magic happens, where the sun's incredible energy is born. Now imagine a place hotter than anything you can fathom. A place where temperatures reach a staggering 15 million degrees Celsius. It's a heat so intense that it defies our understanding, a realm where the very fabric of matter is transformed. That's the sun's core, a colossal furnace fueled by nuclear fusion. This is the powerhouse of our solar system, a place where the laws of physics are pushed to their limits. Here, under unimaginable pressure, hydrogen atoms are constantly colliding and fusing to form helium, releasing an unbelievable amount of energy in the process. This fusion process is the very essence of the sun's power. It's like billions of hydrogen bombs exploding every second. The energy released is so immense that it travels from the core to the surface, taking thousands of years to reach us. This energy, my friends, is what powers the sun and bathes our entire solar system in its life-giving light and warmth. It's the reason we have daylight, the reason our planet is habitable. Think about it. Every ray of sunshine you feel, every plant that grows, every ice cream cone you melt under the summer sun, it all traces back to the unimaginable nuclear reactions happening deep within the sun's core. The sun's energy is the heartbeat of life on Earth. It's a humbling thought, isn't it? To realize that our very existence is tied to the fiery heart of a star millions of kilometers away. The sun's blazing heart is not just a source of light, but a source of life itself. Now you might be wondering, just how old is our sun? Well, let me tell you, it's no spring chicken. At a sprightly 4.6 billion years old, the sun is considered a middle-aged star. That's right, it's been steadily shining for billions of years, and it's got billions more to go. To put that into perspective, if the sun's lifespan were compressed into a single year, humans would have only existed for a few fleeting hours. It's mind-boggling to think about all the cosmic events the sun has witnessed in its lifetime. And here's the kicker. Our sun is just one of billions upon billions of stars in the Milky Way galaxy, each with its own story to tell. It makes you realize just how vast and ancient our universe truly is. Now let's shift our gaze to the sun's atmosphere, a dynamic and ever-changing region that's full of surprises. This vast expanse is not just a simple outer layer, but a complex and fascinating environment that plays a crucial role in the behavior of our solar system. Unlike Earth's atmosphere, which is relatively thin and composed mostly of nitrogen and oxygen, the sun's atmosphere is a wild and turbulent place. It's a realm where intense magnetic fields and high-energy particles create a chaotic environment, vastly different from the calm skies we experience on Earth. It's divided into three main layers: the photosphere, the chromosphere, and the corona. Each of these layers has unique characteristics and plays a distinct role in the sun's overall structure and behavior. The photosphere is the layer we see from Earth, the sun's visible surface. This is where sunlight is emitted, and it's the part of the sun that we are most familiar with. It's a roiling sea of plasma that's constantly churning and bubbling. The movement of this plasma generates the sun's magnetic fields, which can lead to solar flares and sunspots. Above the photosphere lies the chromosphere, a thin layer of gas that's heated to tens of thousands of degrees Celsius. This layer is visible during solar eclipses as a reddish glow around the sun. And finally, we have the corona, the outermost layer of the sun's atmosphere. This layer is much hotter than the layers below it, and its temperature is one of the great mysteries of solar science. The corona is a wispy halo of plasma that extends millions of kilometers into space. It's this layer that we see during a total solar eclipse, appearing as a stunning, glowing crown around the sun. It's incredibly hot, reaching millions of degrees Celsius, but we still don't fully understand why. Scientists continue to study the corona to unlock its secrets, hoping to learn more about the sun's influence on the solar system and beyond. We've already touched upon nuclear fusion, but let's delve a little deeper into this incredible process that fuels the sun. It's a phenomenon that not only powers our solar system's star, but also holds the potential to revolutionize energy production here on Earth. Imagine, if you will, the tiniest particles in the universe, hydrogen atoms, colliding with such force that they fuse together, creating a new element, helium. This isn't just a simple collision, it's a high-energy dance of subatomic particles. This fusion process releases an immense amount of energy, which we experience as light and heat here on Earth. The warmth of the sun on your skin and the daylight that brightens our days are all thanks to this powerful reaction. It's like E equals mech squared in action, folks. Einstein's famous equation perfectly describes how mass is converted into energy during nuclear fusion. The sun is essentially a giant nuclear reactor, converting about 600 million tons of hydrogen into helium every second. This massive conversion process is what keeps our sun shining so brightly. That's the equivalent of detonating millions of atomic bombs every single second. The sheer scale of energy production is mind-boggling. And the best part? This process is incredibly efficient. Unlike other forms of energy production, nuclear fusion produces minimal waste and has the potential to provide a nearly limitless supply of energy. The sun has been fusing hydrogen for billions of years, and it has enough fuel to keep going for billions more. This long-term stability is what makes nuclear fusion such an attractive option for sustainable energy in the future. Now let's talk about sunspots, those dark blemishes that occasionally appear on the sun's surface. You might think that sunspots are cooler than the surrounding areas, and you'd be right. But don't let that fool you, they're still scorching hot, with temperatures around 3,500 degrees Celsius. So, what causes these dark spots? Well, it all comes down to the sun's magnetic field. Sunspots are areas of intense magnetic activity, and they appear darker because they're slightly cooler than the surrounding plasma. Think of them as giant magnetic storms on the sun's surface. And just like storms on Earth, sunspots can be unpredictable and sometimes even violent. Speaking of the sun's magnetic field, did you know that it's incredibly powerful? In fact, it extends far beyond the planets in our solar system, creating a vast region called the heliosphere. This magnetic bubble protects us from harmful cosmic rays and interstellar dust. Think of it as our sun's personal force field, shielding us from the harsh realities of interstellar space. But the sun's magnetic field isn't always so benevolent. It can also unleash powerful bursts of energy known as solar flares and coronal mass ejections, which can disrupt satellites, knock out power grids, and even create stunning auroras here on Earth. Let's talk more about those solar storms, shall we? Solar flares and coronal mass ejections are some of the most powerful explosions in our solar system. Imagine billions of tons of plasma being blasted into space at millions of kilometers per hour. When these eruptions are directed towards Earth, they can interact with our planet's magnetic field, causing all sorts of havoc. We're talking about communication disruptions, power outages, and even damage to satellites. But there's a beautiful side to these solar storms too. When charged particles from the sun collide with atoms in Earth's atmosphere, They create those breathtaking displays of light known as auroras. So the next time you see the northern or southern lights dancing across the sky, remember that you're witnessing the awesome power of the sun. Now I know what you're thinking, will the sun shine forever? Sadly, no. Like all stars, our sun has a finite lifespan. Don't worry though, it's not going out anytime soon. It still has about 5 billion years of fuel left in the tank. But eventually the sun will exhaust its hydrogen supply and begin to fuse helium into heavier elements. This will cause it to expand dramatically, transforming it into a red giant. When this happens, the sun will engulf Mercury, Venus, and possibly even Earth. Talk about a bad day for the inner solar system. But don't despair by then, humanity will hopefully have found a new home among the stars. Have you ever wondered how long it takes for sunlight to reach Earth? Well, let's do the math. Light travels at a staggering speed of 299,792,458 meters per second. That's fast. The distance between the Sun and Earth is about 149.6 million kilometers. So if we divide the distance by the speed of light, we get, drumroll please, about 8 minutes and 20 seconds. That means that the sunlight warming your face right now left the sun over 8 minutes ago. It's a mind-bending thought, isn't it? We're literally basking in the afterglow of the sun's past. Finally, let's talk about the sun's sheer size and mass. It's hard to comprehend just how massive our sun truly is. It contains a whopping 99.86% of the total mass in our solar system. To put that into perspective, if you took all the planets, asteroids, comets, and everything else in our solar system and combined them, they would only make up a tiny fraction of the sun's mass. It's like comparing a grain of sand to a bowling ball. The sun's immense gravity is what holds our entire solar system together, keeping the planets in their orbits and preventing them from flying off into the vastness of space. Thanks for watching. If you enjoyed learning these incredible facts about the sun, make sure to like, subscribe, and hit the bell icon for more amazing content. We've only scratched the surface of what there is to know about this celestial powerhouse. There's so much more to explore out there in the vast expanse of our universe. So keep looking up, keep asking questions, and never stop wondering about the cosmos.